Hey y'all, welcome back to my channel Land Before Time with your host Littlefit. If you didn't get that reference, you probably grew up on Dinosaur Train. Either way, welcome aboard. Today we're going to be taking a look at evaluate reverse Polish notation. If you lost your math skills in high school, have no fear. As long as you have budgeting skills, that's all the math you'll need to successfully solve this problem. You're given an array of strings tokens that represents an arithmetic expression in a reverse Polish notation. Evaluate the expression. Return an integer that represents the value of the expression. Note that the valid operators are addition, subtraction, multiplication, and division. Each operand may be an integer or another expression. The division between two integers always truncates towards 0. There will not be any division by 0. The input represents a valid arithmetic expression in a reverse Polish notation. The answer and all the intermediate calculations can be represented in a 32-bit integer. With that said, let's get started. We know that the goal of the problem is to evaluate reverse Polish notation. Let's write that down. And now let's ask some clarifying questions, because obviously we want to make sure we're solving the right problem. The first thing we want to ask is whether or not tokens can be empty, and the answer to that is no. Will the operations always be addition, subtraction, multiplication, division? That is given in the problem statement, which is a yes. What should we do in the case of division when it doesn't divide fully? And obviously this is also given in the problem, truncates towards 0. Can we ensure we're going to have all valid input? So for example, nothing like 4 divides or 2, 2, and the answer is yes, we will always have valid input. And lastly, will the numerical inputs always be int values? Could there be doubles? And the answer to that is always int values. So now that we know what we're trying to solve for, let's go ahead, take a look at some examples, and start brainstorming. Let's take a look at this example right here. 4, 13, 5, divide, plus. And here we can see that we're going to do 4 plus 13 divided by 5. So when we do 13 divided by 5, we get 2 because we're going to truncate to 0 since it doesn't divide evenly. And then we're going to do 4 plus 2, which then is 6. My first approach to doing this would be something like a stack, since a stack is a data structure that allows for first in, first out. So why don't we give that a shot? I'm thinking we will add any numeric value onto the stack, and when we see an operator, we will pop the top 2 elements, operate the expression, and push back the result, so it'll look something like this. Now that we have all of our numerical values here, the next token is an operator. So since we have an operator, what we want to do is we want to go ahead and take our top 2 elements from the stack, and we want to pop them. And then we want to go ahead and solve for this expression, which in this case will be 13 divided by 5, and based off of the rules we know, this is going to be 2. Now, we're going to take the result over here and add this back to the stack. Reason being is because we still have some expressions left to evaluate. Then we're going to go ahead and move on to the next token in our tokens list, which also happens to be another operator. So again, we're going to do the same thing. We're going to go to our stack, pop the top 2 elements, and then we're going to go ahead and add them, which will then be 6. And lastly, we're going to go ahead and push the 6 back to the stack. And since we have no more tokens in our tokens list, at the very end, we can just go ahead and pop off the top of the stack, and that's going to be our result. So in this case, once we pop off the top, the result will be 6. There aren't really that many edge cases in this one. I guess maybe the only edge case that I can think of will be something like this. In this case, it's going to be as simple as pushing 4 onto the stack and then popping it at the very end. Now that we have an idea of what our solution is going to look like, let's go ahead and take a look at runtime and space. In this case, it will be O of n because we need to iterate over all the tokens in our token list. And as for space, technically it'll be n by 2 because in order to have a valid input, half of your operations have to be numbers and the other half will be operators. But in the end, it's just going to boil down to O of n. So space will also be O of n. Let's take 30 seconds to recap our solution. we want to iterate through the tokens list. If the token is a number, we want to add it to the stack. If the input is an operator, we want to pop the two elements from the stack, and we want to push the result in the stack. And lastly, at the very end, we want to pop our only element in the stack, and that's going to be the resulting output we want. And finally, it's time to put your rockstar coding skills to use. And there we have it, evaluate reverse Polish notation. A few thoughts. As you can see, I'm using an array deck instead of a stack. And the reason for that is because a stack is a synchronous data structure in Java, whereas an array deck is not. So it's slightly faster than using a stack. Another thing you probably have noticed is I'm using this thing called a by function, which is basically the Java version of a Lambda function. And the reason for that is it allows me to prevent using a giant switch statement or a series of if statements. This allows for shorter and cleaner code. I'm a firm believer in using the tools you already have to solve the given problem. However, in your interview prep journey, if you can start introducing some micro optimizations, this can give you a slight edge and land that job. You may think, oh, these micro optimizations aren't that important? Think again. I did a Microsoft interview for a similar problem, 2k closest points to the origin. And the interviewer was actually looking for an nlog k solution, not an nlog n solution, even though nlog k boils down to nlog n. I also did a Facebook mock interview where I was asked to optimize my code even though I had already given the optimal solution. Turns out, the interviewer was actually looking for me to reduce the large series of if statements into a map, similarly to how we did it in this problem. If you aren't getting the results that you're looking for, take a look at 1 to 2 new additions in the language of your choice and bring those learnings to the next interview. And that's all, folks. Happy Leetcoding. If you found this video helpful, then give it a like, comment, share, and subscribe. See you in the next one.